Welcome back to another lesson in which we will explore the beauty of mathematics. Today, it's time to discuss trigonometry. Now, trigonometry is the study of triangles. More specifically, is the study of how side lengths on a triangle relate to a given angle. So that is what we will be exploring. Now, before we begin, we'll have to set up definitions. Sine, cosine, and tangent. Okay, these are three primary functions we use in trigonometry. Let's talk about this character here. This circle-looking thing. This is theta, the Greek letter theta, often used to denote an angle. Notice how this is a right triangle. The right angle here. This is angle theta. In this case, we don't know what that is just yet. So sine of theta, sine as a function of theta, is equal to the opposite side divided over the hypotenuse. Cosine of theta is equal to the adjacent side over the hypotenuse. And tangent of theta is equal to sine theta over cosine theta. So what is that? Opposite over hypotenuse. If we're dividing by fractions, we're going to multiply by the reciprocal. Hypotenuse over adjacent. So that is equal to, hypotenuse cancels, opposite over adjacent. So that way, given any two sides, whether adjacent and a hypotenuse, opposite and a hypotenuse, or opposite and adjacent, we can find a way to relate that to the angle theta. Now, these are the three primary functions in trigonometry. We also have cosecant theta, secant theta, and cotangent theta. All right, so cosecant, that is 1 over sine theta. So that is the reciprocal of this. Hypotenuse over opposite. Secant, you might guess, is going to be 1 over cosine theta. So that is equal to hypotenuse over adjacent. And lastly, cotangent is equal to 1 over tangent. Or we could write it as cosine theta over sine theta. This is going to be the reciprocal of this. Adjacent over opposite. Okay, these are definitions. Let's throw some numbers to it so it makes a little more sense. I'm keeping my angle theta, but I'm going to say this hypotenuse is now equal to 5. My opposite side is equal to 3, and my adjacent side is equal to 4. Notice, because it is a right triangle, by Pythagorean theorem, 3 squared plus 4 squared is equal to 5 squared. Okay, so that needs to check out. That still remains valid. So in this case, sine being opposite over hypotenuse. Okay, opposite is 3, hypotenuse is 5. 3 over 5. As a decimal, that is 0.6. Cosine is adjacent over hypotenuse. Adjacent is 4, hypotenuse is 5. So cosine of theta is 4 over 5. As a decimal is 0.8. Tangent is opposite over adjacent. Opposite 3, adjacent 4. 3 over 4. As a decimal, that is 0.75. Okay? If we want to do the reciprocal functions, cosecant, secant, and cotangent. Well, hypotenuse over opposite. 5 over 3. That's going to be 5/3 as a decimal, 1.6 repeating. Secant, hypotenuse over adjacent. Hypotenuse, 5 over 4. 5 over 4. As a fraction, as a decimal, that is 1.25. Lastly, cotangent, adjacent over opposite. 4 over 3. That is 1.33333 repeating as a decimal. Okay, so those are some numbers. Now, before we move on from this, there is a mnemonic you can employ. Some of you may have seen this. SOHCAHTOA. Alright, remember SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So remember that. You can remember these. You should be good to go. Stick around and we'll continue this topic. That concludes this lesson. To see more videos like this one, consider subscribing to my channel. That way, you will receive notifications when I post new lessons. Also, be sure to utilize the comment section below for any questions or suggestions you may have. If you enjoyed this video and learned something new, please click that like button. As always, thank you for watching. I will see you next time.